Hi, my name is Joy Massey, and today I will be presenting on the liver and pancreas' role in chemical digestion. So, when it comes to chemical digestion in the small intestines, it is important to know that it relies on the activities of three accessory organs. And so, accessory organs include the glandular organs, which are the liver, pancreas, and the gallbladder. So, hence this name, accessory. You should note that food does not directly pass through these organs. Instead, they secrete substances that are needed or that aid in chemical digestion of the small intestine. All right, so here we have a picture of the digestive system. And so this is the particular digestive system where it includes the accessory organs. So you can see these are highlighted in a red circle. And so you have the liver, the pancreas, and the gallbladder. So the liver is that large brown organ, and then the gallbladder is connected to the liver. You can see that the liver is split up into lobes, and it contains several ducts, and we'll get into the details of this in just 1 second. And so the pancreas, the pancreas is this smaller organ here, and it's yellow, and it looks like almost like a cob of corn. So today we're going to be discussing the roles of these organs in chemical digestion. So the liver's main role is to produce bile and export it to the duodenum. And the gallbladder, we won't talk much about it today, but it is important to know that its function is to primarily store, concentrate, and release bile when needed. So the role of the pancreas is to produce pancreatic juice, and this juice contains digestive enzymes and bicarbonate ions, which is going to be really important. And then it delivers this juice to the duodenum as well. So first, we're going to talk about the liver. So the liver is the largest gland in the body. And the digestive role of the liver, as stated before, is to produce bile and export it to the duodenum. And it has three main components. So it has hepatocytes, the bile canaliculi, canaliculae for singular, and then heptic sinusoids. So there's a picture here of the liver, and so it is the largest gland in your body. So between adjacent hepatocytes, and it's important to note here that hepatocytes are the main cell of the liver, and they are responsible for producing bile. So between these adjacent hepatocytes, you have grooves in the cell membranes that provide room for each bile canaliculus. So these small ducts accumulate bile produced by the hepatocytes, and from here the bile can flow first into the bile ductiles and then into the bile ducts. Okay, and so then the bile ducts will unite to form larger right and left heptic ducts, which you can see here, and then these will merge and they'll form the common heptic duct right here. So then later, that duct will join the cystic duct in the gallbladder, and then these two ducts will form the common bile duct, which the bile flows from here into the small intestine. So it is important to note that lipids are hydrophobic, so they don't dissolve in water. So let's talk about the role that bile plays in this. So what is bile? So bile is going to be this mixed secreted substance that's secreted by the liver, and it's going to aid in emulsification of lipids in the small intestines. So the composition of this bile, and as you can see here, it has like a yellowish color to it. And it's going to be stored in the gallbladder, as mentioned before. And so the composition includes bile salts, phospholipids, cholesterol, and then the bile pigments, which give it its color. So as stated before, lipids are hydrophobic, so they don't dissolve in water. So we are talking about chemical digestion in the the small intestine. And so the environment of the small intestines is very watery. So this is not good or fitting for these hydrophobic lipids. Hence, hydrophobic means that it does not dissolve in water. So the bowel is going to help aid in emulsification, and this includes breaking down those lipids into smaller components that can be dissolved. So moreover, hepatocytes, they do work nonstop. So bowel will be produced even when it's not being used. So it increases though, however, when fatty chyme enters the duodenum and it stimulates the secretion of gut hormone secretin. So between your meals, this bowel, like I said, it'll continuously be produced, but it's going to be conserved until you need it to break down the fats that you're consuming. So this is where the gallbladder is important, because it's going to store that bowel until the small intestine needs it. More likely like until your next meal. So, and when you'll need to break down what you just ate. So next we'll talk about the pancreas. So here is the picture of the pancreas. And so the pancreas includes acinar cells, which are going to secrete the enzyme-rich pancreatic juice. So these acinar cells, they're going to secrete the pancreatic juice into tiny merging ducts that form two main ducts. And then the larger duct is going to fuse with the common bowel duct. And you can see that in the picture here. So you can see the pancreatic duct, and then it's going to form, you can see it small here where the common duct and the pancreatic duct are merged and they are connected, and then it'll be delivered to the small intestine. So unlike bowel, this pancreatic juice, it's going to be clear, and it's composed mostly of water along with some salts, sodium bicarbonate, and then several digestive enzymes. So sodium bicarbonate is going to be very important because it's going to help serve as a buffer. So sodium bicarbonate is responsible for the slight basicness of the pancreatic juice, which usually has a pH around 7.1 to 8.2. Excuse me, not basic, but more neutral. So this is going to serve as a buffer to the acidic gastric juice and chyme. And it's also going to inactivate pepsin from the stomach and create an optimal environment for the activity of these digestive enzymes, which are pH sensitive in the small intestine. So pancreatic enzymes are active in digestion of sugars, proteins, and fats. So the pancreas produces protein digesting enzymes, but it has to produce these in their inactive forms, because if not, they would start to digest the pancreas. So they aren't going to be activated until they reach the small intestine. On the flip side, however, the enzymes that digest starch, which are going to include your carbohydrates, fat, and the nucleic acids, they're going to be secreted in their active forms because they don't attack the pancreas. And so some of these enzymes include amylase, lipase, and the nuclease. Okay, and so one more thing to know here is that the pancreatic secretion, it is going to secrete just enough bicarbonate to counterbalance the amount of hydrochloric acid that is produced in the stomach. So the key takeaways here today is chemical digestion in the small intestine cannot occur without the liver and the pancreas. The liver's main role is to produce bile and deliver it to the common hepatic duct. And then bile salts and phospholipids are the main components of this bile, and then they emulsify large lipids. And then the gallbladder is going to store, concentrate, and release this bile. And as far as the pancreas, it produces pancreatic juice, which has enzymes and bicarbonates, and then it delivers it to the small intestine through ducts, and then it serves as the bicarbonate is going to buffer the acidity of the chyme, and then it activates pepsin from the stomach and enables the optimal functioning of these digestive enzymes in the small intestine. So this will conclude my presentation. Thank you so much.